class? Our topic for today is power. You can write power. Power can be defined as the time rate in which work is done. I take it again. Per is the time rate in which work is done. Okay? So now mathematically, when we talk about power, we have two parameters there, work and time. Okay? So now mathematically, power is equals to work done all over what? Time. All over time, right?
Yes.
Hello, is that taken down?
Yes.
So now power is work done all over time. Okay? So now recall. So now the SI units for power. The SI units for power. When I talk to you about work done, I said work done. The SI unit for work done is what? Joules, right?
Yes.
So now that of time is what? Seconds, right?
Yes.
So now the SI units for what power is joules per seconds. Okay?
Yes.
That's the SI units. But mostly used is watts. Okay?
Yes.
So now another SI unit for power is also what?
Watts.
Okay? So now that's another SI unit for power. Okay?
Yes.
Do you understand?
Yes.
So now the relationship, take down the relationship between joules per second and what is given as 1 joules per second is equal to 1 watt. Okay? Do you understand? So now that's the relationship. But power also have other units, SI units. That means there are so many other units for power. Okay? Please don't make noise. Okay? So now we said that power can also, that's another SI unit for power can also be 1 kilowatt. Okay? That's 1 kilowatt. This is kilowatts. Okay? That's kilo. It's spelled. Okay? Watts. So now SI units, another SI unit for power is kilowatts. Okay? Kilowatts. So now we said that 1 kilowatt from your own normal money. If we say 2K, 2K has how many zeros? 3. That means kilo. That's 1 kilo is equal to what? 10 raised to power 3. That means 3. Remember you said that 2K is 3, right? It has 3 zeros. So now it's kilowatts. That's 3 zeros. Okay? Then watts. Okay? Do you understand? Okay now. Then we also said another SI unit for power is horsepower. Yes. Horsepower. So now another SI unit, please clean the board. We said another SI unit for power is horsepower. Okay? This is another SI unit for power is horsepower. So now this one is mostly used in engines. Okay? So now we said 1 per horsepower, that's HP. Okay? Is equals to 1 horsepower is equals to 746 watts. Okay? That's 1 horsepower. You can clean the board. 1 horsepower is equals to 46 watts. Okay? So now, these are the relationship and the SI units for power. Okay? We said the first one is what? We've given you the first one is joules per second. The next one, watts. The next one, horsepower. The next one, kilowatts. Okay? So now we are done with that. Remember, from your formula of power, right? You say it's equal to work done. Right?
Yes, ma'am.
All over time, right?
Yes.
Okay? Yes. So now recall. I gave you formula for work done.
Yes.
Which is what? Formula for work done is what? Force times distance. So now recall. That work done, W is equal to what? Force times distance, right?
Yes.
So now what simply means anywhere you see work done, you put its own parameter, okay?
Yes, ma'am.
Please flip the board. And we said that work done is equal to force times distance, right?
Yes.
Hello? This is what we established from the previous class, right?
Yes.
So now therefore, when we had work is equal to power is equal to work all over what? Time. So now anywhere you see work, you put its own parameter, okay?
Yes.
So now it's equal to work done is what? Force and distance. All over time, right? Hello, do you understand?
Yes.
You input the value of work done, okay? So now since we say work done is force times distance, so now when we see work done, we put what?
Force times distance.
Do you understand?
Yes, ma'am.
So now therefore, let's use mathematical terms. P is equal to, I can rewrite it force times distance all over time. Okay?
Yes.
This still not the same thing as this, okay?
Yes.
So now recall, when we say distance all over time is what? Distance all over time is what? Recall that distance all over time is velocity. Hello? Distance all over time is what?
Velocity.
So now recall velocity is equal to distance all over what?
Time.
So anywhere you say distance all over time is what?
Velocity.
In the board. So now we say that distance all over time is what?
Velocity.
So now P now is equal to, recall that we had the other one, force was left behind, right?
Yes.
So now force times, so we said distance all over time is what?
Velocity.
So now when we see distance all over time, we put what?
Velocity.
So therefore, this is another formula for power. Okay?
Yes.
So therefore, P is equal to A V. Okay?
Yes.
Where A is force and V is equal to what?
Velocity. Distance.
So now if you want to find another SI unit for force, recall, we said that this one is measured in what?
Distance all over time.
Which is what? Meter per second. Right?
Yes.
And this one is what?
Newtons.
Newtons. Thank you. So now another SI unit for power, based on this other formula, can be Newton per meter per second. Okay?
Yes.
Do you understand?
Yes.
You don't understand?
Yes.
Okay, I take it again. You understand this one?
Yes.
You understand this one? You don't understand this one?
I understand.
You understand? SI unit for force is what?
Newtons.
SI unit for velocity is what?
Meter per second.
So now it will be newtons per meter. Okay?
Yes.
Newton. SI unit for force is Newton. Newton, right?
Yes.
Velocity is meter per second.
Yes.
Okay?
Yes.
Do you understand now? Which is equals to Newton meter per second. Okay?
Yes.
Do you understand?
Yes.
So now just note the formula. I didn't ask you to derive the formula. You can just allow formula for power should be in watts. Anyone you know or you remember, just leave your answer like that. You can leave in watts, kilowatts, anyhow, okay?
Yes.
Horsepower is still correct, okay?
Yes.
Do you understand?
Yes.
Okay?
-1.
Yes, because let me show you how -1. You say that velocity is distance, right?
Yes.
All over time, right?
Yes.
So now distance is measured in what? Meter, right?
Yes.
And time is measured in what? Second. So it's either you write it meter per second. That's meter all over second. Okay?
Yes.
Or to bring it mathematically, that's your indices. Or is meter. Do you now understand why we have this -1? So it's important. This -1 tells you is per meter per. So now if you just put meter and seconds, it tells you meter seconds, which is not the SI unit for velocity. Do you understand?
Yes.
Any other question?
No.
Okay, now take the board. Example. Take down. Example. That's the example is on the board. A person applies a force of 7 newtons. A person applies a force of 7 newtons and moves the grates 3 meters and move the grate 3 meters. Full stop. This takes the person 9 seconds. This takes the person 9 seconds. This is 9. Okay?
Yes.
That's 9. 9 seconds. Full stop. What is the power? What is the power? Okay?
Yes.
7 newtons, right?
Yes.
Okay? What again? Distance. Which is what? And what again? Time, which is what?
9 seconds.
Right?
Yes.
Is this all the parameters?
Yes.
What are we asked to find? That power is unknown, right?
Yes.
So now recall, in this, we said that power is work done all over time.
Yes.
Is work done given?
No.
So that means the first thing you are going to do is to solve for work done. That's why I had to teach you how to work on work done, so that you'll be able to apply, okay?
Yes.
So now work done is what? So from here is what is force given?
Yes.
Force is what?
7 newtons.
Times what?
3.
Which is equals to what?
21.
21. 21 what?
21
Joules. Please make sure you put your SI unit, else your answer is wrong. If you just write 21, it's wrong. You need to indicate its SI unit. This tells us you are solving for work done, okay?
Yes, ma'am.
So now we have our work done, right?
Yes, ma'am.
It's time given.
Yes.
So now we can now imply what we were looking for, because we were looking for power, not work done, okay?
Yes.
So now power is equal to what? Work done all over time, right?
Yes, ma'am.
So now our work done is what?
21.
Is it 21?
Yes.
Okay.
All over 9.
9. Okay. So which is equal to what? 21 divided by 9 is equal to what?
2.334.
2.334, right?
Yes.
So now we said our SI unit for power is what? Watt, right?
Yes.
That's capital W. Please make sure you put, some of you, even if you put power. Do you understand?
Yes.
I take it again. The first thing, because work done is not given, right?
Yes.
You need to solve for work done. And he said the formula for finding work done is force times distance, right?
Yes.
And force was given, right?
Yes.
And our distance was given.
Yes.
So when you times it, you had 21, right?
Yes.
So now the next thing is our formula for power,
Yes.
which is work done all over time, right?
Yes.
And work done, we had to be 21, right?
Yes.
And our time was 9, which was given. And when you divide it, you have that. Please clean the board. Which is on the board. An elevator. An elevator, which is on the board, that's number 2, can carry a person and several boxes with a total mass of 500 kilograms. With a total mass of 500 kilograms. With a total mass of 500 kilograms. To the second floor of the building. To the second floor of the building. Full stop. If the elevator has a power rating of 1,500 watts. Rating from 1,500 watts. At what velocity can it move the person and the boxes? Is that taken down?
Yes.
At what velocity can it move the person and the boxes? Okay, that's example of what?
500 kilograms.
Okay, what's the second parameter? Power, which is what?
1,500 watts.
1,500 watts, right?
Yes.
Okay, what's our next parameter? That's all. So now we are asked to find what?
Velocity.
We are asked to find velocity, right?
Yes.
That means velocity is not given. This one, when solving it, you need to understand before solving, okay?
Yes.
So now, mass is given and power is given. How do you solve this one? So now, what you need to do is that, since mass is given and power is given, then you are asked to solve this one. You are not asked to solve power, but velocity. We have another formula of velocity, which is what?
Displacement over time.
Another formula for velocity, remember, we said that another formula for power is force and velocity. That was the second formula we solved, right?
Yes.
And here, from the parameter given, power is given, right?
Yes, ma'am.
Velocity, that's what we are looking for,
Yes.
right?
Yes.
But force is not given. Hello? Do you understand?
Yes.
So now recall, since they said this thing this thing from the question, it's elevator, that means it's going up, right? And I told you that when something is going up, that's another work done. That's acceleration due to gravity. Small g is given as what?
10 meters per second squared.
Please always note, small g is 10 meters per second squared, right?
Yes.
So from here, we can solve for our mass. Hello? Do you understand?
Yes.
Okay, so our force then is equal to mg. Because of this meter per second is acceleration, okay?
Yes.
So now you can say mg. Anyhow, it's still force, okay?
Yes.
I told you the formula for force is what? Mass times acceleration, right?
Yes.
Mass times acceleration or mass times. Because because it's an elevator, okay?
Yes.
So now we can use mass times acceleration, okay?
Yes.
So from there, mass times acceleration is mass given.
Yes.
Is acceleration given?
Yes.
Acceleration we have is constant. 10 meters per second squared is constant, okay?
Yes.
So when something is moving down, that there is a gravitational force on the A that brings it down, okay?
Yes.
Which is small g is equal to 10 meters per second squared, okay?
Yes.
So therefore, our force now is what now? Mass was what?
500 kilogram
500 kilogram times what?
times 10 meters per second square.
Which is equals to what?
5,000.
Which is equals to 5,000, right?
Yes.
Is it just 5,000?
No.
5,000 what? Newton. Now we have our force. Okay?
Yes.
Now our force we have. Okay?
Yes.
So now, do we have force now?
Yes.
Was power given?
Yes.
So now we can make velocity the subject of formula.
Yes.
Because we have to find what?
Velocity.
Please, do you understand?
Yes.
Hello, do you understand?
Yes.
So now making velocity the subject of formula, that's V is equals to V, V, right?
Yes.
You make velocity subject of formula. Okay?
Yes.
So now making V subject of formula means divide by the coefficient of V. Okay?
Yes.
Hello, I taught you this in maths.
Yes.
So now V is equals to what? P, that's power. All over what? Force. Hello, do you understand?
Yes.
Making V the subject of formula is you divide by the coefficient of V, which is force, right?
Yes.
So that here will cancel out and V is on its own. Okay?
Yes.
Do you understand?
Yes.
We can move forward, right?
Yes.
So now our power there was power given.
Yes.
Power was what?
1,500 watts.
Okay? So now force is what?
5,000
So now divide 1,000 all over
0.3.
0.3.
Yes.
So now our velocity is equal to what? 0.3. Is it just 0.3? Meter per second. Okay?
Yes.
Do you understand?
Yes.
Okay, now you can leave the board. Has to move a 1,000 kilogram weight on the board from the ground. Please, when solving this one, when they tell you from the ground, that means it's carried from down to up. That's already telling that gravitational, that means you are going to use gravitational field. That's for work done, okay? So now, from the ground to a shed 3 meter, to a shed 3 meter, above, to a shed 3 meter, above the ground, full stop. The robot can do this in 4 seconds. Full stop. What is the power rating of the question?
Mass.
Mass, which is equal to what?
1,000 kilogram.
1,000 kilogram, right?
Yes.
Okay. What's another parameter given?
Distance.
Distance. Which is what?
3 meters.
3 meter, right?
Yes.
What's the next parameter?
Time.
Time. Which is what?
4 seconds.
Is something else given?
No.
What are we asked to find?
Power.
That means power is not given in this one. We are asked to find power. So now from there, recall that they say it leads from a ground level.
Yes.
So now work done. I told you work done in a graph force field is what? I told you is mass times acceleration times height. Please Please always remember, okay?
Yes.
Didn't I teach you this from the previous class? Please don't learn to forget, okay?
Yes.
So now from here, note that when you are bringing this is that you need to solve first for par work done, right?
Yes.
Before you now put, because par is what? Work done all over time, right?
Yes.
So now from here, our mass is what?
1,000 kilogram
Times what?
times meters.
Note this is constant. That's 10. That's G is equals to 10. Times height is how many?
4.
The distance is 3. Mass is 1,000, right?
Yes.
Acceleration due to gravity, that's small g. Because it's from the ground, it's constant, 10, right?
Yes.
And distance was what? That's the height. Is what? 3. So this and this is equals to what?
9,000.
10,000. 9,000. So now our work done is equals to what? 9,000, right?
Yes.
Is it 9,000 what?
Joules.
Joules. Okay? So this is our work done. Recall, we were not asked to find
30,000.
is what? Please be conscious of. So now it's what? 30,000. Right?
Yes.
It's 30,000. Okay?
Yes.
So now recall, we were not asked to find work done. Base par, right? And we said that work par is equals to what?
Work done over time.
Right?
Yes.
So now our work done here is what?
10,000.
All over what? Was time given?
All over 4.
All over 4.
Yes.
So 30,000 divided by 4 is what?
7,500.
7,500. That means our par is equals to what?
7,500 watts.
Watts. Please always remember to put your ISI units, okay? So now this is the answer. Leave the board.